Good morning, friends. Today I am going to discuss about one of the interesting lecture you can say on the topic indexing, or you can say hashing. Okay, how we can perform the hash indexing or hashing in database management system, right? So this tutorial I have already shared some tutorial and some video lectures on hashing in your Google Classroom. If you followed those lectures, you will get the basic concept, but this lecture I'm solely providing for getting you the basic concept of hashing. Some of you can think that if sir, I don't have the concept of data structure, can we understand the concept of hashing? So I will tell you, hashing is a very easy topic. Few questions are coming. You must get minimum 1 or 2 questions from the hashing, and it is very easy to answer, give an answer, and there is no need to require the basic concept of data structure to understand hashing, right? At least from my point of view. Now, let me start a discussion, and then we will give you some example how we can perform the hashing in on the data set. Okay, on a real life example. Now, what is hashing? Let me tell you first what is hashing and what is the problem related associated with the hashing. Suppose, in case of suppose you have a data set. In that data set, there is a student data set. So student data set has certain number of features like student roll number, uh, uh, student name, address, and so on. Right. So in case of normal database management system, how we are doing searching of a particular data. Suppose I want to search a name of a student and its corresponding address, and how we are going to do that, how we can search that name and corresponding address of that student by using his roll number. Why? Because roll number is a unique one. Okay, so by the help of that unique roll number of that student, we are able to find his corresponding information from the database. So we actually searching the index means this roll number is corresponding to the index. Please remember, always we have to make those column or those feature as an index feature which is unique in nature, because the value, if it is repeated multiple times, then there is a very difficult to search a particular corresponding information of that student. Suppose two students have the same roll number, then there is not possible to find which student you are searching. So that's why we are choosing roll number, because roll number is a primary key, always a primary key in your table, student table, and that's why we are taking roll number as the index. Okay. Now thing is that this index searching in database management system is not efficient in nature, right? Why? Because if it becomes very inefficient approach to search all the index values and reach the desired data. That means we are trying to reach the desired data, that are name and address of the student, by searching the index values, and this process will be time consuming process. Okay, really it will take time, because if suppose the student record will be the last one, then we have to search the record one by one as by doing linear search operations, and we will reach, and it will take too much time, as well as it will waste too much effort, too much memory. So in this situation, hashing comes into the picture and gives some advantage to overcome this problem. Now let me first define what is hashing. Hashing is an efficient technique to directly search the location of desired data on the disk without using index structure. What I have said, I repeat again, hashing is an efficient technique to directly search the location of the desired data on the disk without using index structure. That means we are not using index structure. Instead of that, we are using some sort of special type of keys which are called hash keys. Okay, that I will tell you how we can generate those hashing keys, and based on that hashing keys, we are going to search the corresponding record of the table. Now data is stored at the data blocks whose address is generated by using hash functions. Now there are some concepts regarding hashing. So let me share the screen first before I am dealing with those concepts. Now I think the screen is visible to you. Now let me discuss about the concepts of hashing. Now the thing is that uh, hashing has these three concepts: data bucket, hash function, and hash index. Right? What is data bucket? What is hash function? What is hash index? That I am going to discuss. Listen very carefully. It's very interesting and very important as well. Now, data buckets are actually represent the memory location where the data are going to be stored. Okay, the records are stored, and these buckets are also considered of unit of storage. Okay, what is hash function? Hash function is a special type of mapping function that maps all the set of search keys to actual record address. Now, don't get panic. It's a very easy concept of hashing function. Let's try to understand this example. Suppose suppose I have this sort of data that I want to store. Okay. Suppose these are the roll numbers of the student. Suppose which I want to store: 101, 102, 103, 104, 105. And I'm applying a hash function. Suppose I'm applying the hash function. What is the hash function? Suppose h mod 10. hash function I have applied that k mod 10 or each mod 10. What is h equal to k mod 10? K is actually the keys on which you are going to store in your to which you are going to store in your memory location or in your data buckets. These are data buckets or memory locations or unit of storage. You are storing these keys in terms of hashes. Okay, these are the index values 1, 2, 3, 4, 5, 6. Now, how this index value has been retrieved based on this hash function and doing some basic math, basic calculations, we can calculate the index value. So, what I have said, what is the hash function? Hash function represents k mod 10. So, what is k mod 10? K is actually these search keys. Okay, so modulus of 10. That means we actually performing the modulus operation on this in each and individual keys, and we will take the remainder, and the keys which represents the remainder, it will store its corresponding memory location. So suppose 101 I have taken as a key to store, and which memory location I am going to store. These are the number of memory buckets of memory location we have, and we are going to store in which place. We have to just give a modulus operation by 100 of that on that key 101, and what is the remainder? We will get 1. So we are going to store 101 into a remainder 1, right? Into a remainder 1. Now in the same way, we are going to store 102 by dividing by modulus by 100 into a remainder 2. So 2 is the memory location. So that is the basic, very basic concept of the hashing. Now what is hash index? These are called hash index 1, 2, 3, 4, 5, 6, 7, 8, 9. So by the help of search keys, or you can say this data bucket at the place where we are going to store the hash index as well as corresponding memory locations. Hash function by which we can calculate the hash index, and hash index are those which has been generated from the calculation of the hash function. The prefix of the entire hash value is taken as hash index, right? And this table is also called a hash table, where the hash index are actually storing, okay, or consuming. Now there are two types of hashing. Very interesting. Please listen. One is static hashing and one is dynamic hashing. Mostly the questions will come in terms of static hashing, but if the short notes will come regarding hashing in database management system, we have to give an explanation of both the types of hashing, static as well as dynamic. Let me describe a static hashing. Very simple. As the name suggests, what is static hashing? It's very simple. Static hashing is a hashing where the resultant data bucket address will always be the same. That means always the data bucket will contain the same address. That is called static hashing. Don't need to panic. Need to be panic. I'm giving you an example. Suppose we generate an address of employee ID 103. Employee ID is unique. It's primary key in the employee table. So we will take that employee ID to generate the hash keys. Okay, I already told, and we have to apply a hash function that is modulus 5. In last case, I have applied the hash function modulus 100. Here I have applied the hash function modulus 5. So if we apply the hash function modulus 5 on the employee ID 103, what would be this corresponding bucket address or memory address? So 103 divided by 5, that means modulus 5. We will take the remainder. So what will remain? The 3 is the remainder. So the bucket address of this employee ID 103 will be 3. So this 103 will be stored into a bucket address 3. Clear? So in this way, we can and hence there will be no change in the bucket address. So always through the entire process, so how many times you are calculating this 103 by using mod 5, there is no change in the bucket address. Means always this 103 will store into the bucket address of 5. That's why it's called static hashing. Okay, the address of 103 of employee 103 on the hash function mod 5 is always 3. That's why it's called static hashing. Now let me check this example. Suppose this is an employee table. These are the employee IDs, employee names, and employee suppose living cities. Okay. Now these are the employee IDs which is unique. Now I am going to calculate this corresponding hash table or hash key. This is a hash table, or you can say the bucket table. Okay, which is an extra table associated with the actual database table, and this represents the hash indexes or hash values by which we can easily search, or by which we can quickly search any data item into the database. Let me tell you, the normal searching technique will take big of n amount of time to search a record in worst case, whereas hashing technique always take big of 1. 1 means a constant amount of time to search a particular data item. Always it will take a constant amount of time to particularly search a data item. Please remember this thing whenever the concept will come into exam as a question of hashing. Please write these things. The hashing technique always take constant amount of time, that means big of 1, to search a particular data item into a table, whereas the general searching technique will take big of n amount of time Okay, in case of worst case, to searching an item in a table. Clear? Now you can calculate by yourself. So suppose the record 98 I want to store. This is 98 record. Which index it will take? So 98. These are the keys I have fetched. So 98 divided modulus 5. So 3 will be the remainder. So it will store into the memory address or the bucket address 3. So its corresponding record 98 Alia and UK has been stored into the bucket address 3. In the same way 104 modulus by 5. So the address is 4. Okay, 5 into 20 100. So 4 is the remainder. So 4 is the corresponding bucket address where the corresponding record of 104 will be stored. In the same way 106 will be stored into the bucket address 1 and 102 will be stored into bucket address 2 and so on. So this is the way of static hashing is working. And static hashing, in case of static hashing, the number of data buckets in memory remains constant throughout the process. And in this example, we have these 5 data buckets in memory used to store the data. Now, searching, operation of searching. Now, in case of static hashing, how many operations we can perform? In case of normal database, how many operations we can perform? In case of hashing, we will perform the same number of operations, like searching a record, insertion of a record, deletion of a record, and updation of a record. The same number of operations we are performing in case of normal database search. Now everything is related to searching. If you remember very closely, all the other operation, insertion, deletion, updation, are related to searching. Because if you want to insert a particular record, after a particular record, you have to first search the actual insertion place. After which record you are going to insert a new record that you need to search. So searching is required before insertion. Again, in case of deletion of particular record, you have to search which record you have to delete and then delete the corresponding record. And in case of updation, do the same process. So searching is a very basic operation or base operation in any case of database searching or this sort of hash table searching. Now, when a record needs to be searched, then the same hash function retrieves the address of the bucket that the data is stored. Very simple. By using this employee ID, you can just use the same hash function mod5 to get the corresponding address, bucket address. Then you will be getting this particular data, because this hash table will not located in front of you, because it's an extra part. It will be virtual application. It has a virtual existency. So you will get only this data the user will get only this data set. Okay. And when the user searching a particular record of a corresponding employee ID 106, its corresponding hash function will be called automatically in your program. It has been implemented. It will be called, and corresponding hash address, bucket address, and its corresponding record will be retrieved. The searching record is there. Insertion is the same thing. Okay, to insert a particular record, then it has to first search in which location or in which bucket address it has to be inserted. Suppose a new record has come 105, and it will be suppose a record whose remainder is 5 after doing a mod 5 hashing operations, and it will be inserted in the new place of the bucket address whose address is 5, starting address is 5 or index is 5. In the same way 6 can be inserted. Now these are the various situations and various operations that we can perform on static hashing. But there is one problem. Okay, that is the major role why dynamic hashing comes into the picture. Why we need dynamic hashing to overcome the problem associated with static hashing. Now, first we have to understand what are the problem of static hashing that we have to associate. Okay, that are associated, and we don't want in real life situation this problem will create impact on the database management system for accessing data, right? But in real life it will create an impact. Okay, now first let me discuss about the different sorts of problems of static hashing, right? Now the first hashing is called open hashing. The first problem becomes the open hashing, and second one is closed hashing. So these two are the solution of the problem. So these are not problems, they are the two are the solution of the problem. What is the problem? Problem is very simple. Suppose the problem name is called bucket overflow. Okay, bucket overflow means very simple. Suppose 104 is there, right? Okay, 104 whose corresponding memory address or bucket address after doing a mod 5 operation, it will be 4, and its corresponding record has been stored. Now suppose in future, suppose another record will come whose remainder will be similar type of. It may be possible. I will give you the example. Suppose another record will come whose remainder will be similar to the remainder of this 104. That means it will also map into the same bucket address 4. But it is not possible because in the bucket address 4 already one record has been occupied. So there is no place to give the new record to the same address, but its corresponding other addresses are empty. Okay, you can put the record into the other addresses 5 or 6, but the thing is that then it is not supporting the hash function logic. So this is the problem. This is called bucket overflow. Okay, the bucket will overflow to store the more than one data or more than one record in the same memory locations. Okay, and then it's called bucket overflow. And the bucket overflow can be handled by solutions which is called open hashing. The first solution is called open hashing. Very simple. What is the open hashing? Open hashing tells you that, look at the example. If the corresponding memory address is overflow, then you have to insert the new record into the very next memory address when which it is empty, where it is empty, where there is a place to insertion. So suppose there is one more record has come whose memory address is whose hashing address is 4, bucket address is 4. So obviously it cannot be inserted because bucket address 4 has been already occupied by some other record. Now suppose the 5 has been already occupied by some other record. We will assume it. Here 5 is also occupied by some other record. But in the next corresponding address after 4, 5 is occupied, but 6 is not occupied, 6 is empty. So then the very in sequential order it will search which memory address is empty, where the corresponding record is not present of the bucket address. It will simply store that record with address 4 into a new bucket address with a blank memory locations, that is 6. So in this way, open hashing is working. This is an example. So suppose this hash function which will store the value 110 here, but this is occupied, so it will store the next value 113. Okay, in the next place, which is actually empty. Okay, it is empty because 113. If you remember, if you do the hashing of 113 with a hash function of 110, oh, with a hash function of 100, 100, then 3 is the remainder. Okay, sorry, somehow 3 is the remainder, but 3 is already occupied by some other value 110, and suppose the fourth bucket address position is empty, and then it will follow the linear probing. That's why this arrow has been given to show the linear probing. It's sequentially search. Suppose if that position is also occupied, then it will search the next one. If that position is also occupied, then it will search the next one, and so on. Okay, and this entire concept is called linear probing because we are doing a linear search. Linear search means one by one, bucket by bucket, one address of the bucket to another address of the bucket. That's why it's called linear probing. This entire approach is called linear probing, and it's a part of open hashing. So when a hash function generates an address at which there is already stored, the next bucket will be allocated to it. Very simple, which I have already discussed. Now the second type of hashing, which is called close hashing. So to understand the close hashing, we generally require the concept of linked list data structure. Okay, linked list data structure. But right now I don't want to discuss about linked list data structure. It's a totally defined concept. But one thing I need to require, that suppose I am giving one real life example. Suppose one friend comes to your house to live. Okay, suppose he has some sort of function or some sort of show in Kolkata, and your friend comes from suppose Bhopal, and he doesn't know anyone here, so he's a very close friend. He wants to live in your house, and suppose in your house it is already occupied by some other relatives. So there is no single space or single room to give to your friends. Okay. Now what you will do? You will first, you are not, obviously we are not rudely tell that you can't leave, you go for the hotel or for other purposes, you arrange by yourself. We can't tell that because he is my best friend. So what should I do? I will go to my another friend house, which is my local friend, and I will tell him, please give him a room for one day or one night to stay. My friend, he is my relative. Now my friend has give his a room to my friend, okay, to stay. So I actually know the address of my friend house where my friend who is coming from Bhopal will stay. Now it may be possible that I actually pointed my friends to the address of another friend's house in my locality, right? Now suppose I didn't go with him, I will just send him the address and send him to my friend's house. Now my friend has is my local friend is also one of my best friend, and he doesn't tell me that we don't have space in my house, because already he also has some relatives has already occupied his house or his home. So what he will do, he will again take my friends and he will go to another friend's house of his friend's house to give him that particular opportunity of living, right? So this is called chaining process. Okay, So overflow can be resolved by using chaining process. Okay, so this is called overflow chaining. Okay, so let me give me one example. There is a overflow chaining I have already discussed. So suppose a new data value has inserted. Suppose 6 has to be inserted. Suppose 5 is a mod function is called 5. It is also this condition of bucket overflow is also called collision. Collision terms is very important because sometimes instead of bucket overflow, collision term is also using. Okay, what is collision? This is called collision. It's the same address has been located by more than one data, then it is called collision or bucket overflow. Now, if a data has been already stored into that particular address, suppose 6, and the new data has to be come, suppose it is 11, which contains the same address, suppose 5, the mod 5 function I'm using. So 6 mod 5 means 1 is the remainder. So it will index by one bucket address. And now 11 has new data has come. So 11 mod 5 means what? 5 into 2, 10. So 1 is also a remainder of the 11. So it will also need to occupy 1 into the bucket address 1, but it has been already occupied by 6. So now 6 will give the pointer or a linking locations to 11. Pointer concept, all of you have the pointer concept because C you already know, you have already learned the subject. So the index 1 or bucket address 1 pointing to the data value 6, and the data value 6 pointing to the data value 11. So no one is lost. Okay, everyone is has its information or address to its previous one. Okay, this is called a chaining process or close hashing. Okay, and linear hashing or open hashing I have already told. Linear probing process I have already discussed. Now this is all about the hashing problem. Now let me just show you some problems, how this sort of problems will come into the exam. Suppose there are some data values has been given to you and the hash function has been given to you, x mod 10. What is x? X is the set of data values. Okay, x1, x2, x3, x4 and so on. Now which of the following statements are true? So these are the 4 statements that get questions, so that's why the multiple choice option has been given. So among all these 3 addresses of the same value, or these 2 address has the same value, all elements has the same hash value, or each element hashes to defined value. That we will have to check whether all these addresses have the same hash value. Okay, or these 3 elements have the same hash value, or only these 2 elements have the same hash value, or each element has different hash value. Which one is correct here? Now to check it, we have to do the calculation. We have to apply the mod 10 operation for each and individual elements and try to find its corresponding remainder. So if we apply mod 10 on the first element 9679, this element, so 9 is the remainder, then 19899 is the remainder, 41999 is the remainder. So in this way we'll apply the hash values for all these elements. Okay, these 3 and these 2. Why we are not going to apply? It is not going to apply in the solution, but not going to apply for all the values, because as per the according to the option it actually doing. So you can also apply the same concept for all the values, because it will actually waste your time. So as per, if you have the multiple choice, but in WBT, if this sort of question will come in MCQ, then you can do in this way. Or if it will not come in MCQ, then you have to apply the concept for all the data values. Now then we will check which one has the same bucket address. This is actually bucket address. After applying hashing function, it will create a bucket address. So these 3 have the same bucket address. So as per the options, the first option is correct. That means 9679, 1989 and 4199. These 3 data values has the same hash value. Okay, this bucket address means the hash value, the same concept. Bucket address, hash value, these 2 are the same terms using simultaneous. Okay, and 1471, 6171 has the same address. Okay, so here option 1 and option 2, these 2 are the correct options. So option C will be there, 1 and 2 only. Okay, now this option C is the correct answer. Now second one is insertion of keys. Okay, how we can insert these keys? These keys are these actually the data values. Okay, initially at the empty hash table of length 10, using the what is the length of the hash table? 0 to 9, 10. Okay, and using the hash function k mod 10. So modulus 10, where k is actually this key values. Okay, or you can say data value. Now linear probing has to be applied. Why linear probing? Because there is a chance of collision here. Okay, so that's why they have told you the solution. Linear probing you have to apply. So linear probing is a part of static hashing. What is the resultant hash table? So these 4 hash table will be given to you, and you will have to tell you the correct answer, which one is your resultant hash table after satisfying these all conditions. Now start with the first key 12. Now 12 mod 10, you can do it by verbally. 12 mod 10 means 2, so it will store in the first position 2. So this is the correct answer. This first answer will be closed. Okay, So B, C, D. Okay, these three are the correct answer. Now 18. So 10 mod 18 means 8. 8 is the storage or bucket address of the key value 18. Now 13, 3 is the key value of the 13. Now 2. The 10 mod 2 means 2. Okay, so 2 is the bucket address of 2, but 2 has been already occupied by a key value, data value 12. Okay, so we'll apply which type of conditions? Linear probing. Okay, so linear probing means we can either doing a chaining operations. Okay, linear probing means either we can do the chaining operations or we can searching on empty locations where we can put the values. So here in linear probing, actually we are searching empty locations linearly where you can put the values, and chaining, if it will take instead of linear operation, if it will take chaining, then we will do comma comma. So this sort of action is actually applied for option number D for the chaining process. Okay, and this option number C will be applied for the linear probing. I think you can understand. So 2 will be applied in the next empty bucket. Which one is the empty bucket here? 4. Address 4 is the empty bucket. So 2 will be placed here. Now again we will calculate for 3. 3 modulus 10 means 3. So 3 has been already occupied 13. Now next we will search the next corresponding empty bucket. That is 5. So 5 is the empty bucket. So 3 will be stored into 5. Okay. Now because this 5 you can't consider. Why you can't consider this 5? Because 5 has come later. Okay, one by one you will have to do it. Now 23 mod 10 means 3. So 23 will be stored again into the location of 3, but again we will set the empty bucket. 6 is the empty bucket, so 23 will store into 6. Okay, now 5. Now 5 has been already 10 mod 5 means 5. So 5 has been already occupied by the memory location, by the data element, by key element 3. So it will search the next empty location, that is 7. So 5 will be stored into 7, and last 15 will be occupied by 5, already by occupied by element 3. So 15 will be stored the last memory empty memory location 9. So this is your answer. This should be your correct answer. So option number C will be your correct answer. So this is the correct answer, option number C. So this sort of numerical problems maximum it will give. Okay, and I think you can understand it's very easy to solve and very interesting to learn about hashing. Now the last thing that I need to tell about the second type of hashing, which is called dynamic hashing. Generally numerical problems will not come in terms of dynamic hashing. Only need to know the concept. Dynamic hashing is such a hashing which will overcome the problem of static hashing. It's very simple. Static hashing, what is the problem of static hashing? Bucket overflow. Suppose the same memory location, more than one data value is trying to store into the same bucket address. So it's not possible. But in case of dynamic hashing, this bucket size will grow and shrink as per the record inserted or deleted. So this method is called extensible hashing method, and the method makes hashing dynamic and it allows insertion deletion without resulting in poor performance. Okay. Now these are the way of how to search key, how to insert record. I think you can understand. You can do by yourself. I just give you the understanding how we can do the dynamic hashing here. Okay. So I will leave this part of discussions for you for the preparation at your home. So prepare it. If you have any problem regarding dynamic hashing or static hashing, please ping me on Google Classroom. So thank you for listening my lecture. I will close it down. Okay.